Okay, the next question is quite difficult. The two graphs below represent the variation with the distance d for d equal r and 2d equal 2r of the electric field and the electric potential around an insulated point charge. Electric field, distance. The work done by an external force in moving a test charge Q from 2r to r is equal to Q multiplied by which concept ABCD, or where is it? The question is external work. Work, we know that is the force times the distance. Here we have the distance, 2r minus r, okay? 2r minus r. So we need to find the force. The field, this vertical axis is the field, and this is the potential difference. Okay, so we have two graphs and we need to choose which one, the area of the graph 1 or the graph 2. And it is said that we need to multiply Q with the area here. This area in the graph 1 means the field times the movement, the displacement d, and that is the variable field. So that is actually the integration. Let's say this is e times dx and integration, and when we multiply this with the charge Q, the product QE here is the force. So that integration with force and distance, which gives the work. Okay, so that is the answer. The shaded area of the graph 1 under graph 1 multiply with Q to give the work. Okay, not graph 2. F equal QE. E is the variable, so this is a variable force also, so that we need to take the integration, which is the area. If you have learned integral in math, the area of the shape is calculated by this integral. For example, in the mechanical part, we have a constant accelerated motion, the velocity like this, and the time, and the velocity increases linearly like this. It is described as a function Vt equal V initial V0, okay, plus AT. So this is the equation of time. V0 is the initial velocity, okay. And to calculate the distance moved, we calculate this area. We use this distance equation using the equation of the trapezoid. Wait, what's that, trapezoid? Yeah, the trapezoid. But because you have study integral, now we can apply the integral. In this case, the integral of this function v0 plus at and dt, okay, from time 0 to the time t here, 0 to t. So that because v0 is a constant, so we take v0 times the time t plus at square over 2, right? And then put the two, I forgot what is it called, 0 and t, like a lower limit and upper limit, huh? Yeah. So we will have the distance traveled to be vt plus 1/2 at squared. And it also, of course, can apply to any function, not just a linear function like this. To have the area to be the distance. A charged particle is moved at constant speed between 2 points in an electric field. The work done between the 2 points is determined by constant speed, 2-point field, work done, value of the charge and the path taken, value of the charge, path taken, speed, 2-point in electric field. Okay. This is an entirely strange new question to you. So you have to remember two things. Firstly, between 2 points, the potential difference will be constant. Potential difference, because the potential difference only depends on the position, the location of the charges. Okay, the potential difference delta V is constant. Secondly, an electric field is called a conservative field. Conservative field. Conservative field means that the work done by the force of the field does not depend on the path. No matter it move like from A to B, it can move straight, it can move as a curve, it can move very long anyway and end up at B. The work will be the same no matter the path. Okay.
Yep.
Work the same no matter the path, as long as it moves between only those 2 points with a constant potential difference, no matter the path. The gravitational field is also a conservative field, but we didn't study about it. And the question about conservative field like this is rarely, extremely rarely seen. So if you forget it, it's fine.
Okay.